Welcome back to the C++ tutorial course, and we're going to look at today, which is session number 3, looking at arithmetic commands. If you haven't seen any videos before, I've got a whole course based on C++, starting with session 1 looking at creating variables, session 2 was employing variable arrays, and today at session number 3 we're going to look at arithmetic commands itself. If you haven't seen them, please go back and have a look at them. Feel free to ask me any questions in the comment section below. I'll try to answer them uh, as quick as possible, to be honest. Let's have a look at the 2 or 3 learning objectives for today's session. And the first one looks at understanding the use of arithmetic functions. So we're going to look at the basics itself, and then we start building it up. And then later on, we're going to have a program which we can go looking at it from line to line, and hopefully deepen your understanding of arithmetic functions and the operators itself. The second learning objectives is based on understanding the use of arithmetic operators and manipulations. So we're going to look at how to manipulate values and how to update our empty containers, which we kind of introduced in session number 1. And the third learning objectives, we're going to look at extended arithmetic sum functions, where we're going to look at increment, decrement, and modulus. Let's have a look at a bit of a theory. So when we look at arithmetic functions, some people kind of get confused and say, oh, what do you mean by that? It's basic maths terms. So as we can see up here, we got the first 4 operators which we use in basic maths, which is your addition, which is well, displayed as a plus, very similar to maths. Second one looks at subtraction, which is a minus. Star is associated to multiplication, and division is obviously your slash itself. So the extended functions we're going to look at is modulus, increment, and decrement, which I will circle up below for you here, and we can look at that hopefully at the program, and that kind of should deepen your understanding of it. It's a very simple program. We're going to look at that in a second, but nothing to worry about. So all you need to remember right now is that we have our 4 operators which are coming from the maths itself, which is addition, subtraction, multiplication, and your division. Modulus, increment, and decrement, we can look at an example. So when we create our maths functions or any association to maths, obviously we can set up an argument where we can use A, B, C, which are your different data types. So we can have ins or floats depending on if you have a number with a whole number or a number with a decimal point. But it's very similar to maths. When we have our our complex mathematical equation, we need to start breaking it down and then start working from step to step. So I've got an example up here, which is the first one. I'll draw a small cross next to it, or a star. It's very unclear. We don't know exactly how do we start that equation or how to break it down. On the next star, or the line below, you can see that once we start breaking it down and start sectioning things off, it becomes more clearer, or it becomes more structured for us to start working on our equation. And the modulus, which is represented with a percentage sign, looks at a very simple kind of a concept. If we have 2 numbers and we divide them, if there is any remainder, it will give you output of 1, and if there is no remainder, it gives you an output of 0. So all it does gives you ones or zeros, and it's quite handy if we want to find out if the number is odd or even, which we're going to look at later on within the series, where we're going to use modular functions to start comparing strings and so on and so forth. But for now, all you need to remember is when we start with our modulus operator, all it can do is divide 2 numbers, and if there is a remainder, it will give you an output of 1, and if there is no remainder, it will give you an output of 0. The next one, the next 2 operators are based on increment and decrement. Now, when we create a variable and we want to use loops or statements where multiple versions of that statements are executed to fulfill a statement itself, it's very important that we can set a number of loops. So, for example, it's very similar to an iPhone example or any mobile phone or any smartphone itself. You have a password set up on the phone, And if you try to log in and you type in the password wrong, or your fingerprint doesn't get recognized, it will give you a hit saying that please try again. So internally it will count 1, saying that you've tried it once and you didn't get through the phone, so you didn't go through security. If you do it again and the password or the fingerprint is not recognized, in your case the password is wrong, it will count as 2, and most probably on the third wrong attempt it might lock your phone or it might be disabled for a certain amount of time. Now we can do it 2 ways. We can set it up as the maximum being 3, or it can start from obviously from 1. So you do 1 attempt, second attempt, third attempt, it locks it out. Or we can count down from 3. So the minute you get your phone and you try to unlock it, it'll say, okay, you got 3 attempts. If you got it wrong, from 3 you got 2 left, from 2 you got 1 left, and from 1 basically it locks out itself. It does the same job, it's just can be modeled in a different way, if that makes sense. So the increment looks at obviously increasing the loop or the variable or the value itself by 1, and decrement, with represented with a double minus, looks at it decreases the value by 1, and it's called basically look at postfix and prefix. That's how the technical words for it. Let's have a look at the next slide, which is the program. As you can know, within the series we always have a program associated with an example, so which kind of helps to visualize using empty boxes or empty containers to see exactly what happens. So let's start up. The first line itself is your library, so that's where all your main 5 data types are stored. In this case we're only using one data type, which is int, so again we still need the library to obviously associate int to the C++ program. Int main, with the 2 brackets, starts the program, then the curly bracket to start off the program itself. And the first one is this statement up here, which asks the program to create 2 variables called a and b, which are in green, and associated 2 values to it, and obviously their characteristics are int. So if we draw 2 boxes, that's the first one, that's the second one, both of them are int. That means both of these variables can hold a whole number only, any number, but it has to be whole number, so no value with a decimal point, and it has to be a number itself. And the first box is called a, the second box is called b. So that's a good one. So let's create our boxes, which you've done, and let's have a look at the associated values to it. So this one says a equals 8, and the second one talks about b equals your 4. So within a we put a value of 8, and in b we put a value of 4. So that's all the association with variables we've done. And the next one, if I draw a small bracket up here, looks at shout out messages. So it doesn't do anything other than just basically doing basic maths, as you can see up here, and giving us the value. So this one is saying box A plus box B. So this one gives you basically 8 plus 4, because 8 is box A and 4 is box B, and the answer should be 12. So on the next slide, once we've done this, it will give us the answers, which are pre-compiled for you. We can start matching it up if all the answers are right. The second one looks at a minus b, which is 8 minus 4, and the answer should be 4. The next one looks at a times the value of b, so in our case is 8 and 4, so 8 times 4, and it should be 32. The next one looks at a divided by b, which is 8 divided by 4, and the answer for that is 2. That's the operator we just talked about on the previous slide, which is the modulus. And in this one, let's break this one down a bit further. So a is your 8 and divided by 4, and the answer should be 2. Now what it looks at is, does 2 have any decimal point? Does it have anything left over? So any decimal points itself. So for example, when we divide 8 divided by or 10 divided by 2, we should get 5, or 10 divided by 3, it should give us 3.6 if I'm not mistaken, or sorry, 3.33. So in that case, because you've got a decimal point associated to it, it should give you an output of 1 because there is a remainder available for it. In this example up here, you don't have a remainder. 8 divided by 4 gives us a whole number, which is 2, and the answer for that modulus result will be 0 because there's no remainder associated to it itself. Now let's look at the postfix, which is your increment, which is your plus plus statement. So what this one looks at is a, add 1 to it. So what we have is 8, as you know, a is 8. We increase it by 1. So if I draw plus plus. Now what that means is at this moment in time, 8 has been added or has been increased by 1. But the answer for that will be still 8 because we have not called the variable again. We just basically said to the variable box up here, which I'll circle up for you, it's you have got 8 in there, can you please increase it by 1? But if you haven't asked the program yet, what is the new variable a called, or what is the new value associated to it? We haven't asked for it. So all we just gave a command is basically increase whatever is in the box a, increase it by 1. Well, the program says, fair enough, I'll do it, but it won't give us a recognition, or it won't give us a result as of such. On the next one, looks as the postfix result. What we're doing up here, we're not doing any mathematical calculation to it. All we are asking for the system is, can you tell me what A is? What is in the box A now? And what it will do now, it will go back to the box and see, okay, what happened previously? You wanted 8 to be increased by 1. Have you done it? The system obviously hasn't done it. So as it's asking for the new A, it will give us a result A, which is 9. Because now 8 has been increased by 1. The third, the C out within that section up here, talks about prefix. So prefix is something similar to your postfix, and prefix, what it does, it adds it by 1, or it keeps 1 ready, or it keeps the increment of 1 ready before you give the variable itself. So what we have up here is plus plus, and the variable is b, which b in this case, which I've circled up for you, is 4. Now what we're doing up here is slightly different to the postfix, which we've done a few lines above, is where we increased 8 by increase it by 1, but we haven't asked what the variable is, because obviously the plus plus is after the variable. So the variable is 8, then we increase it by 1, but we don't ask for a again till the next line for it to be reassociated to the higher number, which is 9. What we're doing up here is, because b itself is 4, and the plus plus symbol before the variable talks about increasing it by 1 already. So it's very similar to having 1 ready, and when you get the variable, just basically merge it together. And that's why the answer for that is a total of 5, because it has been increased already before we asked for it. So we have plus plus, it increased it by 1, and once we got b, it became from 4 straight away to 5. So the answer for this line up here, which I've underlined for you, is 5. And what we're doing is, on the next line itself, we're asking again, can you just repeat what's in the box B, which in this case, again, it hasn't been altered, so it's 5 itself. So let's have a look at the next slide to kind of see if all of these results make sense. So I've basically, in the previous sessions, which I've explained, is I've pre-run the program already, screenshot it and actually put it on the PowerPoint, which saves us obviously going to the compiler and just basically copy-pasting the code into it and seeing what it does. So as you can see, it's exactly the same program, and the sections below up here, which I've circled, are basically the outputs and basically the answers for the equations up below. So the first one talks about a plus b, if you have a look at that, and the answer was 12. The second one looked at a minus b, which we said 8 minus 4 is 4, so that's right as well. Second one was multiplication, 8 times 4 is 32. The division itself talks about 8, which is up here, I'll circle it for you, a divided by b, and that's the answer is 2. The modulus, if you remember right from the previous slides, it talks about the remainder. So what we have, the equation up here was a divided by b, And the answer is 2. Do we have any remainders left? Which in our case is 0, so that's right as well, what we did. The postfix talks about the section up below, which I've signed or circled up here for you, which is A is 8, and 8 increased by 1, which in this case is still 8, but because as I explained on the previous slide, we haven't increased it yet. We have increased it, but we haven't asked for the new variable association to it. On the next one, we basically just asking the program, can you just tell us what's in the box called A? And which it will verify and give you a 9. The last two sections looks as the prefix, so that's where we use a different variable. It's the b, not the a, and it's plus plus 4. So we increase, we have one already ready if you want to remember it like that, and we increase it, well, we have the increase ready, and we associate it to the variable b, which is 4, and the answer for that straight away is 5, because we have asked for the variable at the end, and the plus pluses are before the variable, not after the variable. If it is after the variable, then we obviously have to ask for the variable again to be updated. And the answer for the prefix one, as you can see up here, which I'll circle up for you, is plus plus b, and the answer is 5, because we already have increased it by 1 as the variable came up. And the last one talks about, just tell us what's in the box b, and the answer is exactly the same, it's 5, because we haven't done anything with b yet. And obviously then we have our return 0, which obviously ends the program itself. Now we have few tips on each of these sessions. I recommend that you kind of take a note of them, and as we go through the series, certain tips will come handy when we come to bigger problem solving situations. But I hope you liked this session, and I hope I see you back for the fourth one, where we're going to start looking at much more complex mathematical issues, or even strings itself, which is later on within the series. But if you have any questions, drop me a comment below, and I will try to answer it as soon as possible. But I hope you enjoyed, and I hope I see you back later. Well, thank you.